Mentally math!
Let's get mental!
Alright, that is pretty focused.
Are we recording?
Yes! Alright, so give me a minute to get out ahead of me, blah blah blah.
What do you mean by 60 increase 50%? Does it mean like add 50% to 60?
Yes. Add 50% to $60. Yeah, it's the same kind. We've been doing these. But good to get that phrasing down to get the kind of English that implies the math. Critical. Okay, gotta take a couple of deep breaths. I'm sure you're got a few of these done. Okay. All right. So, this is actually the same as yesterday. Instead of them being right next to each other, we're just squaring it. Oh, why don't we not do that? 18 rule. Okay, so it's just negative 1/2 times negative 1/2 is 1/4. Then we could say 9 times 6 is 54, but we're in scientific notation, so I put a little decimal there, which means I'm dividing it by 10. Thus, instead of saying to the power of 15, I need to multiply it by 10 one more time over on this side. So I'm going to say to the power of 16.
16.
Mm-hmm. Yeah. That's a lot of powers. Okay then. Moving right along. 9 plus 1 is 10 divided by 4 is 2 and 5/10, or maybe you can say 2.5 as well. Then 1,000 millis in a liter. So that'd be 1,500 milliliters. Then 150, there's an extra and in there. 150% of 60 is adding 50%. So it'd be $90. And thus, increasing 50% is the same thing. Different phrasing, $90. Alright, changing 1/5 to a decimal in percent. Decimal could be 0.2%, 20%. Okay. Alright, so start with the number of minutes in half an hour. Multiply by the number of feet in a yard. Add the number of years in a decade. That's kind of fun.
Yeah.
A little for mathematical riddle. Keep us on our toes. Then find the square root of that number. It's 10.
That was really hard. I couldn't solve it.
Yeah, that was pretty simple. Yeah. Okay, so. All right, today we're talking about how to make money with math. Money. And to some extent, some of this is a bit more of a discussion than asking for you to do that. Yeah. So simple interest, compound interest, and and successive discounts. So simple interest, and actually they only in the book. I just realized in the book they only talk about simple interest before the first example. So here, let me just clear my ink here, and I'm just gonna work in like this space here. So interest is essentially a percentage of money that has been borrowed one way or another. Now, either you've put money in the bank and saved it there, which is technically like the bank borrowed money from you. because now they can use that money to make money, do investments, that sort of thing. So they're going to pay you a little percentage of the money that you've given them. They're going to pay a little bit of that back out. It can also work the other way around. That's what credit cards are, and why we're going to get a quick discussion about why credit cards are incredibly dangerous.
Yes, they're so bad. So much.
Yeah. Is that? Yeah, we'll show how that works. And so essentially, you borrow money from the credit card company, and then you have to pay them a little bit of a percentage of the amount of money that you borrowed in order to, as a payment for them lending you that money.
That's good for you. A little bit. That's $24.
Well, okay, so let's take the book says say $100, okay, and let's say the level of interest is 6%, right? So now 6% is what decimal?
0.06.
Right.
Or
So,
you multiply 100 by 1 and 1 600.
right. So essentially we get the amount of interest by multiplying it by the percentage. Let's say over a year. Is annual interest is normally a thing. So say you write, you do that and just kind of multiply it by that. So for the percentage, so say over 1, 2, 3, 3 years, you might say, okay, well, so if it's over 1 year. The book does something kind of strange here. Anyway, so say after 1 year, then you would need to pay how much interest?
6%.
Yeah, 6%, which would be how many dollars? $6. Now, let's say it was not compounding. And we'll see what compounding is. So let's say you only actually had to pay up the interest after 2 years. So 2 years of interest would be what? $12. And like three years would be like $18. But that is not how it works. How it works is it compounds. So alright, so let's go right here. So our example number 1 here is we're making a table that shows the value of a $1,000 investment growing at 10% compounded interest annually after 1, 2, 3, 4, and 5 years. So let's say now this is actually a wildly profitable.
Yeah. If you graph it, actually, it's crazy. If you
Yeah. So this is actually a little unrealistic in terms of a actual bank account you would get. It's really high.
Yeah.
Now one thing though is you can get really high interest rates. Maybe it's still not this high, but you can get really high interest rates. Like say my daughter has a college fund, say, and one thing about that is now if you have a college fund, if you're like putting money and saving for college, there's probably not much chance you're taking that out. Like we got when she was like first born. Like we're not going to be using that for like 18 years, right? Yeah. So you get a really nice interest rate for that because you're not taking it out. They're pretty much guaranteed you're not going to take that money out, and they've got that money to work with for that amount of time, and they can count on that. So they give you a good interest rate. But of course, if you try to take it out early, they've got like a big penalty for that to try to keep people from doing that. So you actually lose. I don't know what the penalty is, but just to say. So this is a pretty high, like if you were making money on the interest rate. But think about this. Now, is this going to help move us forward? Because I'm going to try to move us forward. Okay. So think about this, of how this works as compounding interest goes. So say after the first year, it's a 10% interest. So by having your money in there, instead of having $1,000 in there, they've added $100 because it's they add 10% after the end of the year, right? So now you've got $1,100. You're following so far?
Yeah.
Except now now the money that they're working off of to give you your interest is now 110. Is now $1,100. So now they're adding $110 to that.
Oh.
Right. So at year 2, you have 1,200.
So this is how much
That's how much they're paying you to keep your money there. So now you've got $1,210. But of course, now for year 3, now that's what they're taking the 10% off of, right? So now they're adding $121, right?
That's a lot of money.
So year 3 now you've got $1,331. So just the spoilers on how this keeps going forward. So now you're adding $131.10. So now year 4 you've got $1,464.10, and now they're working off of that for the 10%. So now they're adding $146.41. So in 5 years.
Me and Nora have to go to a student council.
Oh, okay. You can watch the rest of the video later. Right? Okay. Watch the rest of the video later, guys. Have fun at student council. Alright, so now, in 5 years, now keeping in mind this is a bit of an unrealistic figure for how much interest you do make, but you can kind of see this gets crazy fast, right?
Yeah.
Like it's not. Yeah, like it really compounds. So here's something you can think about now as far as credit cards go. As far as credit cards go, if you borrowed money, 10% is actually very, very, very low. 15% is very low. So think about if you borrow $1,000 on a credit card, how fast you're losing money on that because they're compounding that against you. Does that make sense?
Yeah.
Yeah. So yeah, 15% would be actually quite low. So think it's much worse than this. And in fact, like I've got like an Amazon credit card that we use just to buy at Whole Foods because we get a 5% discount on our groceries at Whole Foods with it. But we better pay that off every month and make sure that balance is zero because that's got a 23%.
Yeah, it's 18 to 24%.
Right?
18 to 24%.
So we keep that at absolute zero because if we left any money there that we owed, it would start compounding at a very, very rapid rate. 2.5 times as fast as this. Maybe more, actually, when we think about that. Okay, good talk.
Wow.
So that can kind of show you why credit cards could be really dangerous, right? But also why long-term investments can be very profitable.
Credit cards are not dangerous unless you focus and do things correctly, but they can be dangerous if you slack off.
Yeah, there you go. Okay. Okay, so example 2. How are we doing? 1, 2, or 3 on that last bit? How are we doing? Okay.
1, 3. Can I put 5?
Well, might break the fabric of the image. Oh, a little trouble. Okay. I mean, so for people that weren't quite at a 3, though I think 2 is about the lowest one I saw. It's essentially every year they're taking 10% and adding to it, but they're adding 10% to what the new amount is. So every time they're adding, they're making it bigger, and so that means they're adding more.
Are you getting the money or are they getting the money?
Oh, you're getting the money. That's why this is a little unrealistic, but
Well, why is it hard for you?
Huh?
But why is it bad for you?
Oh, well, no, I'm saying now this is an investment. This is where you're getting the money. I was just saying that this is a good example of why if this was, instead of this being your investment, this was how much you owed on a credit card, how fast that would start to get out of control. Right? But the actual example is make a table that shows the value of a $1,000 investment that's growing.
That's crazy.
Right. So this is an imaginary bank account, savings account where they're adding a 10% interest rate, which is a little bit over the top as far, but they're trying to make a point. Maybe a 3 to 5% would be considered good. Yes.
So basically, you're taking 10% of every total you get.
Yeah, so every new amount, they're taking 10% of the new amount and adding that. So that's what's growing it so fast.
Yeah.
So, okay. All right, so we're going to use the calculator I downloaded. So this one is use a calculator. So this calculator is a little bit iffy because it actually kind of fires the front of the number off of the edge, but it shows it in little numbers underneath it. You'll see. So use a calculator to find the value after 12 years of a $2,000 investment that earns 7.5% interest compounded annually. Okay. That's a bit of a mouthful there. Okay. So yeah. I mean, they're still. I mean, I guess something that you would have to be. You have to keep it in there for 12 years is the rule. So they're giving you a really good. They're really getting a good rate at that at 7.5%. Like I said, like 3 to 5% would be considered actually good. But the rule is you have to keep it in there for 12 years. So they give you this nice amount of interest on it. Okay, and so we're starting with $2,000. Wish me luck here on this thing working correctly. And then, then times. Now, of course, we're timesing it where we're doing the thing of like, remember mental math, we're increasing it. So we're timesing it by 100, and 7.5%. Right? Because otherwise I would get a tiny number. I would just if I just said 0.075, then I would just get that. So that's what you get the first year. But that doesn't work. So for what we're trying to do, we're saying okay, 2,000, but we're taking. Well, let me demonstrate. We're taking. Well, maybe you should not talk over me doing this. Would be nice. Thank you. Especially when I'm asking you to stop. And your question could probably be answered by allowing me to continue. So our 100%. No, I'm doing that again. Stop distracting me. All right. Times. There's the helpful part. So 107.5%. So our new amount is going to be 2,150. So that's 1, but we're doing 12 years, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And so that's how much you have after 12 years.
$4,763.
All right, invest your money wisely, kids. All right. So that's an example of how that can work. Okay, so now I bet you can figure this out. However, let me just give you a hint on it. So calculate the interest earned on an $8,000 deposit in 9 months if the annual 1-year interest rate is 6%. So in case you're feeling a little bit stymied, I'm sorry, I'm getting diminishing returns on that one. In case you're getting a little stymied on that one, just think that your step one is figure out what the interest you'd get on 1 year is. And then ask yourself, but it's not 1 year, it's 9 months. So what mathematical operation could I do to figure out from the amount that it would be for 1 year, figure out how to modify that for 9 months? Think about it. I bet you can figure it out. Did you figure out what you just want to tell me?
Oh yeah.
Well, well, let's wait on that. Let's let people. Okay, so you're not trying to get the amount in a year. We found out how to get the amount for a year, right?
Yes, but also I kind of got a question about that.
Huh?
I kind of got a question about that. Why was it 1.075?
Oh, because I don't want to just know the amount of the interest. I want to know what it's going to be, like the amount that I have plus the added amount of interest. So I'm basically multiplying it by 107.5%. In order to know 100% is the amount that I have, and then adding the 7.5% to it. Otherwise, like say the first time, I just multiplied it. I just got the interest on the first year by multiplying it by the interest rate of 7.5%, but that gave me 150. But what I wanted was the 2,000 plus the 150. So it was 1 times 1, which is times, just give me the number back that I gave you, plus the extra amount, 107.5%. Does that help?
I know, but okay.
Okay.
Wait, can I see like the calculate? Can I see what to do the?
I hit it one extra time. That's maybe what's confusing you between looking in the book. Okay, I'm not moving. I'm not going back. Okay, so your first step would be just to get the interest, right? So that'd be $48. Or $480, excuse me. Okay, so if you got $480, but we're not doing 1 year, we're doing 9 months. So, what could I do to modify that to be from the amount of 1 year to 9 months? And he's been really patient. He has his hand up immediately. Yeah.
So you can multiply it by 9/12 or 3/4.
Right. Well, and why do it by 9/12, right? Though the book does it by 9/12. So yeah. So essentially. So yeah, you could multiply it by 9/12, but well, actually that cross cancels fairly good. Well, doesn't it?
Oh yeah.
That actually kind of cross cancels pretty good. Yeah.
Yeah, but
So.
this one's also nice.
Yeah. Okay, so let's see. There are 4 of those. Or 4D. Right. Okay, so 40. And then 4D times 9 is 360. Ta-da!